Okay, so you've got now 3 assessments coming up. The first one is probably next week, Monday. Okay. And so that will be a Socrative quiz. Okay. So somewhere, something or the other, you need to bring something on which you can connect to the Wi-Fi and answer a quiz like that. I have not finally decided on what section that quiz will be. I think in terms of the fact that you have those 5 sections on which you have not been assessed, I will, okay. That will be an open book socrative. In terms of the 5 sections that you are going to need to learn for your cycle test the following week, or your class test on the Thursday. So you've got 5 sections on which you haven't yet been assessed. Photosynthesis, cell respiration, nutrition, gases exchange, and excretion. These 2 sections are going to be in the Thursday test that week. Okay? So not this Thursday, next week Thursday, you're going to have a test on photosynthesis and cell respiration, a class test. Okay. The cycle test, which is currently scheduled for the following week, Tuesday. So that's the 30th, is going to be the other 3 sections. So that's going to be nutrition, gases exchange, and excretion. Okay. What's the matter, Puppet?
It says that next week Tuesday we have a math cycle test. But I don't know if that's
not next week Tuesday. So next week, you've got the two class things. The following week, the 30th.
Yes, on the 30th it says we have a maths test.
It's moved to the 3rd of July.
Okay, I can't keep up with everything that moves.
Okay, so was that a class test or was that a cycle test?
It's moved.
Okay, so in the staff meeting on Friday, Mr. Javier did say that there might be some movements of cycle tests. But at the moment, the schedule that I got last week, Friday morning, said that on the 30th there is a cycle test for life sciences, which may or may not be on the 30th.
Gases, excretion, nutrition, and
gases exchange. So we've got 3 things we need to schedule, or we have scheduled. The one is the socrative, the one is the class test, and the one is the cycle test. Okay. In theory, the cycle test is currently on the 30th of June, and that is on 3 sections. That is on nutrition, gases exchange, and excretion. The class test, which is on the Thursday, Chloe, what date's that?
That is on the 25th.
Okay. Bear in mind, however, that they are going to change the timetable again between now and then. If I don't have the 2 classes for 2 consecutive doubles, I would have to shuffle it around in that week. Okay? The only reason why it's on that Thursday is because that's the day I've got 2 consecutive doubles with you guys. So that test is on photosynthesis and cell respiration. Okay, you happy? So those are the 5 sections on which you haven't yet been assessed. What do you want your Socrative to be on? To help you, to best help you with learning. Remember, open book.
I'd say either gases, exchange, or excretion, because those are the biggest sections.
Do you want a combination of it?
We'd rather do one or the other.
Okay. My feeling is excretion is slightly more complicated. Because gases exchange, you sort of more, it happens, and I know it happens, and whatever. Excretion with that nephron structure, I think, is a little bit more complicated. So your Socrative, so it's open book. Chloe, what's the date? The Monday. 22nd of June. Okay, so it's open book, and it's on excretion. Okay, right, is that happy? You're right with that? Yes, I'm listening. I think that those might be genetics, though, in which case you're in trouble. Right. Okay. So how are we in terms of the synapse story? Thanks, that was an awesome, comprehensive answer.
I think we're doing well now.
Okay. Alex,
Yes.
synapses.
What about those?
How are you?
Sorry, Mom?
How are you in terms of synapses?
No,
This is really not a higher grade question.
Sorry, Mom, I'm just a bit dead. I'm honestly quite confused, but I think I'll start understanding soon.
As many times when I feel I don't get paid enough. Then
Yes, ma'am?
okay, this is a general question. I'm going to ask all of you. So when I get to you, don't go, yes ma'am, what ma'am?
I'm feeling good. I just need to go over it again, just to refresh my brain.
No, you're good.
Good. Yay. Okay, so can I go over it quickly for you? Okay. So remember that a synapse, okay, are we looking? Okay, a synapse would be where one neuron connects to the following neuron. So the first neuron we're going to call the presynaptic neuron, and the second neuron we're going to call the postsynaptic neuron. Okay? So remember, if that is the sequence along which an impulse passes, then it will be, okay, are we all looking? This is the presynaptic neuron's terminal branch, okay? And where there's a swelling at the end of the terminal branch, remember that is called a synaptic knob. Okay. Then there is a little space called a synaptic gap or a synaptic cleft. And on this side of it would be the dendrite of the postsynaptic neuron. So this is that dendrite of that neuron. And this is the synaptic knob of the previous neuron. So remember that neurons never touch each other.
Mom, where is this located, or is it everywhere?
It mostly in the central nervous system, but it is possible that it would happen elsewhere.
Thank you, Mom.
Okay, especially where, and I haven't mentioned this, I mentioned it last week, but I haven't mentioned it today. This may be where a neuron actually ends on an effector organ cell. So this might in fact not be a neuron, it might be a muscle cell, in which case it will be all over the body. That kind of thing is everywhere, but between one neuron and the next neuron is more within the central nervous system. Okay, all right, we're happy. Okay, so remember that in a synaptic knob, there are two important things. There are many mitochondria, and then there are also synaptic vesicles, and those synaptic vesicles, remember, contain chemicals called neurotransmitters. Okay. So remember that what happens is when an impulse passes along a neuron, it'll happen as an electrical impulse. So it's going to be electrical. Electrical cannot pass across this gap. And remember that the synaptic gap is filled with fluid. So it'll be electrical right up until the synaptic knob, but it cannot be electrical crossing this little gap here. So when the impulse reaches the end of a neuron, it changes from being an electrical impulse to being a chemical impulse. So remember that what happens to cross this gap is when the electrical impulse reaches the synaptic knob, some of those vesicles migrate to the surface and they fuse with the membrane of the synaptic knob. And when they do that, those vesicles open up and they release neurotransmitters into the synaptic cleft. Those then diffuse across the gap and they combine with the receptors in the postsynaptic membrane. Right? Does that make sense? So they will diffuse across the gap. So if that is a synaptic knob of a presynaptic membrane, and this is the dendrite of the postsynaptic membrane, remember that the vesicles with neurotransmitter, when the impulse reaches the synaptic knob, some of those vesicles go to the surface, they fuse with the membrane of the presynaptic knob's cell membrane, and they release neurotransmitter into the synaptic gap. And neurotransmitter diffuses in that liquid across the gap. Okay? You right with that, Alex? Hey. Okay, so remember, on the other side of the gap, on the postsynaptic membrane, that there are little channels. So they're really like a gate. Okay, they're little channels and they are closed. So when those little neurotransmitters migrate across the gap, they're attached to a receptor site on those closed channels. So they're attached to a little receptor site, and when they're attached to a receptor site, it's like a key in a lock. Don't say that in a test or exam. And what that does is it opens the channel. When the channel is open, ions that are freely available, there are always ions present in this liquid. When those little channels are open, the ions are able to flow in and they start an electrical impulse in the postsynaptic cell. Okay, so it becomes electrical again. It's important that that channel closes again, because otherwise it causes complication and ions just carry on flowing in, etc., etc. So it's important that little channels, those gates, the receptors, the proteins, close again. But to get them to close again, that neurotransmitter has to be removed from the receptor site. So where that little key was attached in the lock, don't say that in a test or exam, it has to be removed so that the channel can close again. Okay. In order to get it to be removed, what has to happen is an enzyme that is also present in the fluid in the synaptic gap breaks down the neurotransmitter. Okay? So when it breaks the neurotransmitter down, it removes it from the channel and the channel closes again. Then remember what normally happens is the components of that broken down neurotransmitter are taken up again and reassembled and made into neurotransmitter to be reused again. Okay, you happy?
Can you say reabsorbs?
Okay, you happy? Yep, no, definitely, maybe.
Yes, ma'am.
You sure?
Yes, ma'am.
Okay. Jen? You okay?
Yes, ma'am.
Alex?
Yes, ma'am.
You sure?
Yes, ma'am.
Okay. Alright, so won't you do for homework, a flow diagram? And remember, what are the rules of a flow diagram? Hey, go. Rule 1. Rule 1. Let's do this in sequence. Jenna. You put a heading, Mrs. Page, because all diagrams in biology always have headings. Okay, so you put a heading. Firstly, you have to start a new page. Because I've just marked 1,000 grade 12 tests where they went over 2 pages and I nearly beat them. Okay, start a new page. Put a heading. It's got to go down the page. What are the important things, rules about the little parts of it? Chloe.
Has to be one statement per line. Well, in between each arrow. You can't have like 2 sentences.
No, I'm fine with that. Okay. Is it a statement?
It's a phrase.
It's a phrase or a word. You may not have any the and whole sentences and full stops and things like that. It's got to be a short phrase. Are you allowed to have clouds, Zimpiwe?
No, ma'am.
Okay. No clouds, no boxes. Last 2 short. Alex, what's a face?
Mom, what do you mean no boxes? So do you not draw the squares around it?
Oh.
You just do the arrows.
The arrows between. And remember, it's going down the page. So all those little steps that you did, Alex, in life sciences, there be no boxes. So you're not going to go, idiot, took memory card from video camera. You're not going to go, a box, or worse still, a cloud, and then put an arrow down. Okay?
Okay, thank you, Mom.
Right. We happy? Okay. Alright. So here are some common examples of neurotransmitters. Acetylcholine, dopamine, norepinephrine, or noradrenaline, and serotonin. You don't have to learn those. Don't learn them. Yep.
I'm sorry. So just going back to when, I don't know what to call them, that gets reabsorbed. into
the components of the neurotransmitter.
So when that gets reabsorbed, does it form a vesicle again?
So those are the little breakdown parts of a neurotransmitter. First of all, they're reassembled, and secondly, they are incorporated in a vesicle.
Thank you.
Okay. And remember, that is the part that requires all the energy, hence the many mitochondria. Okay. Are people at home because it's cold?
I don't know. I think a lot of people have themselves or family have underlying health issues.
No, but everyone was here last week.
Also, like some people, I'm also speaking to my one friend, she's also at home, she came last week. They're getting quite scared because a lot of cases have come up in schools in the past like 2 weeks because people are coming back. Yeah. Now, can I ask you something a bit off topic?
Try.
It's about with photosynthesis and cell respiration. I was making notes on the weekend. And do we need the role of ATP? Can I show you which section it is?
Very simplistically.
So,
Can I summarize it in one little paragraph for you?
yes, please.
Okay. Alright, so it goes like this. Wait, listen. Kids are obsessive writers. You drive me insane. Okay. Listen first and then I'll say it again.
Okay.
Okay. So, there's energy in food molecules. Okay. So, where do cells get the energy from? They get the energy from food molecules. That energy in food molecules is in a form that cells can't use it. So when a cell needs energy right now, it can't get it from that food molecule. Okay, so it's like having a gold bar in the bank. Okay, you've got a gold bar, it's in a storage box in the bank, you've got money, but you can't use it if you need it right now. When you go to the shop and you need to buy supper, you can't use that gold bar to buy supper. Okay, that's what energy is like when it's in food. Okay, so in order to take the energy out of food and convert it to a usable form, that process is cell respiration, and it happens in all cells 24/7, 365 and a quarter days per year. That energy is taken out of food and it's used to make a substance called ATP. And ATP is banknotes. Okay, it's banknotes. So ATP is a readily usable form of energy. And so remember that ATP is adenosine. And adenosine is able to link to 3 phosphate groups. So adenosine plus 1 phosphate is adenosine monophosphate, AMP. There's a little bit of energy in that bond. So if you broke that bond and made adenosine monophosphate into adenosine and phosphate again, a little bit of energy would be released. Does that make sense? Or adenosine can bond to 2 phosphates and form ADP. There's more energy in that bond than there is in that bond. So if ADP is broken down to AMP and phosphate, some energy is released. Or adenosine can bond to 3 phosphate groups and make ATP. There's lots of energy in that bond. There's more energy in that bond than in that one, and there's more energy in that bond than in that one. So if ATP is broken down to ADP and phosphate, because ATP can be broken down to ADP and phosphate, then lots of energy is released. And that's readily usable energy. There's a lot of it, and the cell can use it immediately. So this is banknotes. Okay, energy and food is your gold bar in the bank. Energy and ATP is banknotes that you can use in a shop. Okay, it's easily usable. There's more energy in that bond than there is in that one, and there's more energy in that bond than there is in that one. So when a cell's doing its energy transactions, it tends to use ATP rather than ADP or AMP, because ADP is a 100 Rand note. What have I just said? ATP is a 100 Rand note. No, it's a 200 Rand note. AMP is a 100 Rand note. No. ATP, 200. ADP, 100. AMP, 50. Okay. That makes sense. All right. You're okay with synapses, Papa Pies?
Ma'am, if you learn the PowerPoints on Moodle for photosynthesis and cell, do you think we'd be okay?
Yes, because your textbook has far too much detail. What I didn't do at that stage of the game, because it was pre-lockdown, is I didn't put okay. Right. Okay, off we go.
The reward pathway in the brain is a complex network of millions of nerve cells. Signals travel along the reward pathway from one region of the brain to another. Nerve cells communicate with each other at a junction called the synapse. Here, signals move from one neuron to another. The small space between the two cells, called the synaptic cleft, is where the action takes place. The cell that will send the message is loaded with sacs, called vesicles, that are filled with neurotransmitter molecules. There are many types of neurotransmitters. The type used along the reward pathway is dopamine. The cell that will receive the message is coated with dopamine receptors. An electrical impulse triggers vesicles in the sending cell to dump their contents into the synaptic cleft. The dopamine molecules attached to the receptors on the receiving cell, dopamine and its receptor, are specifically shaped to fit like a lock and key. When dopamine is stopped, the receptor triggers the production of a signal.
This works in a slightly different way to the opening of the channel thing. There are different ways in which the neurotransmitters make the postsynaptic neuron work, and the one way is not through opening channels. It's actually if the neurotransmitter attaches to a receptor, it makes something be released in the following cell. So it's a slightly different way of doing it. Okay.
Like a messenger molecule. Dopamine is released from the receptor and it goes back into the sending cell through reuptake transporters. Here, it will either be packaged for reuse or broken down. The second messenger can interact with other molecules to produce effects within the cell. It can also trigger an electrical impulse which travels down the axon. Our receiving cell is now a sending cell, and the process repeats. The impulse reaches a synapse